11.2, areas of regular polygons. Remember what regular polygons are. Regular polygons are polygons where all angles are congruent, all sides are congruent. Goals in this lesson are to be able to find the area of equilateral triangles and to be able to find the area of any regular polygon. Let's start with equilateral triangles. First thing is to remember what the formula is. Remember, for the formula of an equilateral triangle, the area will be equal to 1/4 times the square root of 3 times the side squared. Although they don't tell us this is an equilateral triangle, we know that it's an equilateral triangle because all three sides are the same measure. All three sides are congruent. It's an equilateral triangle. All we have to plug into the formula is how long are the sides. So you have 1/4 times the square root of 3 times the length of the side, which is 6 squared. Using a calculator, this problem then becomes simple. Punch it into your calculator. If you have a scientific calculator, you may get the 9 square root of 3. We don't want to leave it like that. Once you round it to one decimal place, you would have 15.6 units squared. Alright, pause the video, try to work the second one. Now realize in the second one we do have a equilateral triangle because we've got 3 congruent angles. If the angles are congruent, all 3 angles are congruent, we know that all 3 sides are congruent, so it is also an equilateral triangle. Pause the video, give it a try, and come back and check your answer. Alright. If you solved it correctly, you should have found that the area was equal to 48.5 units squared. If you did not get 48.5 units squared, check and see, did you use the correct formula? The area is equal to 1/4 times the square root of 3 times the length of side squared. If you used the correct formula but you still did not get the correct answer, make sure that when you punched it into your calculator that only 3 was under the radical and that you put parentheses around the 4 square root of 7 with the square on the outside of the parentheses. In some calculators, it may make you put a multiplication symbol between the square root of 3 and the parenthesis, but most scientific calculators you would not need to put the multiplication symbol there. Make sure again that the only thing underneath the radical, should be the 3. Okay? Alright, let's move on to area of regular polygon. I forgot about this example. We do need to discuss this one. In this problem, you are asked to find the area of an equilateral triangle. Problem is, the formula is area is equal to 1/4 times the square root of 3 times side squared, but they haven't given you the length of the side. Instead, what they have given you is the perimeter. The perimeter is 21 centimeters. Well, you have to remember this is an equilateral triangle. All 3 sides are congruent. Perimeter we know is equal to the number of sides times the length of a side, and what we need to know is what is the length of the side. The perimeter is 21. This is a triangle, so there are 3 sides. How long are the sides? Divide both sides by 3. You find out that the sides would be 21. Now that you have the length of the side, you can take that, put it into your formula. The area then would be 1/4 times the square root of 3 times 7 squared. Punch that into your calculator. After punching this into your calculator, you should have found that the area was approximately 21.2 centimeters squared. Alright, let's move on to area of a regular polygon. In this checkpoint, we're asked to find the area of a regular polygon. Remember, to find the area of a regular polygon, area is equal to 1/2 times the apothem times the perimeter. Problem is they have not given us either one. They have not given us the apothem. They have not given us the perimeter. Remember, the apothem is a segment drawn from the center of a polygon to the side of the polygon. It's the distance from the center to the side. So we make that perpendicular. We don't know the apothem. I'll label that with an A there. To find the apothem, we need to realize that what we have here is a right triangle. But on this right triangle, we only know one side of the right triangle. We know what the hypotenuse is. One side of a right triangle, remember, is not enough to solve a right triangle. To solve a right triangle, you either have to have two sides of the triangle, or you have to have one of the acute angles. Remember from our terms that a central angle is an angle formed by two radii. So if we put two radii together, we have a central angle. Remember, to find a central angle, you need 360 divided by the number of sides. Well, this polygon has 6 sides, so we would take 360 we take 360 and divide it by 6. We find the central angle is 60 degrees. Now, in the right triangle that we're using here, with the apothem and the radius, when we are not using the whole central angle, we're only using half of the central angle. Because remember, the apothem does two things. It bisects the central angle and it bisects the side. So half of that 60 would be what the measure of this angle would be. 60 divided by 2, or 30 degrees. Because this angle is a 30-degree angle, what we end up with is a 30, 60, 90 triangle. Makes this problem a little bit easier than some of the other polygons that we will have. Remember, in a 30, 60, 90 triangle, you have your short side, which is our important side. To get from the short side around to the hypotenuse, you multiply by 2. And to get from the short side around to the long side, you multiply by the square root of 3. Remembering your 30, 60, 90 will make finding the missing pieces on our polygon a little bit easier. We know the hypotenuse of this 30, 60, 90 triangle. It's 8. We want to go backwards from the hypotenuse to the short side down here. Well, if we multiply by 2 to get from the short side to the hypotenuse, then to go backwards, we would divide by 2. So since the hypotenuse is 8, this short leg would be 4. Then to get from there around to the long side, which is our apothem and part of what we're trying to find, we would multiply by the square root of 3. So the apothem over here would be equal to 4 times the square root of 3. Well, the apothem is one of the numbers that we need in our formula down here. We needed to know how long the apothem was. So we can begin the formula. Area is equal to 1/2 times the apothem, 4 square root of 3, times the perimeter. Perimeter we still do not know. Remember, for the perimeter on a regular polygon, perimeter is equal to number of sides times length of a side. Now when we're talking about number of sides, we mean the number of sides on the entire polygon. This polygon has 6 sides. Then we want to multiply that times the length of a side. Well, right now what we have is half the side. We know that half of the side here is 4. If half of the side is 4, the other half is 4, so the whole side would be 8. So put 8 in for the length of the side. Now you can find your perimeter. 6 times 8, or 48. This 48 should be put over here into your area formula so that you have 1/2 times your apothem times your perimeter. Using your calculators, punch this into your calculator. 1/2 times 4 square root of 3 times 48, and you will find that your area will be equal to 96 square root of 3 if you're leaving it as a simplified radical, but we would prefer the decimal answer to round it to one decimal place. You would have 166.3 units squared. Remember, this is area, it's always units squared. Okay, let's look at another example. This one we were able to take a shortcut. Can't always do that, only if you have a special right triangle, either a 30, 60, 90 triangle or a 45, 45, 90 triangle, but you don't always get special right triangles. Let's look at one more example. Alright. first thing we want to know is what's the formula. Remember the formula to find the area of a regular polygon. Area is equal to 1/2 times the apothem times the perimeter. You want to look at the triangle and see, or polygon, and see what you're given. You were given a radius. So it's helpful to draw the right triangle. You would always want to draw one side of your polygon. Draw your apothem perpendicular to the side. Draw your radius. Now the radius is what they gave us. We know the radius is 12. What we are missing is the apothem and the perimeter. Let's start by finding the apothem. Notice that using your apothem, your radius, and half the side, because remember your apothem bisects the side, we form a right triangle. We know one side of the right triangle. That by itself is not enough information. We would need an angle measure also. To find the angle measure, we first find the central angle by taking 360 and dividing it by the number of sides. Well, the polygon over here has 5 sides. It's a pentagon, so we would divide by 5. We would find that the central angle is 72. Now remember, not only did the apothem bisect the side, it also bisected the central angle. The central angle is formed by 2 radii. This whole angle is 72, but the apothem bisects that 72, so what we need is half of the 72, or 36 degrees. So this angle that we're using is a 36-degree angle. Now we want to ask ourselves, from that angle, what is this side? Okay. Using your SOHCAHTOA, you can figure out which trig ratio you will need if you're trying to find this side that's adjacent, and you know this side over here, which is the hypotenuse. Adjacent and hypotenuse, you would want to use cosine. So, to find your apothem, you would use the cosine of the 36-degree angle would be equal to the adjacent side, which we have labeled A, over the hypotenuse that they have given us, which is 12. To solve this equation, multiply both sides of the equation by 12, so you end up with 12 times the cosine of 36 degrees is what your apothem is equal to. This is what you'll want to put into the formula for the apothem. So we'll come down to our formula, 1/2 times the apothem. The apothem is 12 times the cosine of 36 degrees. But we also need the perimeter. Remember, to find perimeter of a regular polygon is always equal to number of sides times length of a side. We know this polygon has 5 sides, we just don't know yet how long the sides are. Remember, on the right triangle that we're using, that we've drawn inside of our polygon, the apothem bisected the entire side and cut it into 2 equal pieces. We now need to find out how long this piece of the side is, half of the side. We want to find this side that's across from our angle, that's called our opposite side, and we'll use the hypotenuse that they had given us. So opposite and hypotenuse, looking at our trig ratios, you can see that that would be sine. So we take the sine of the 36-degree angle would be equal to the side opposite the angle over the hypotenuse. To solve for x, we would multiply both sides by 12, so that x would be equal to 12 times the sine of our 36-degree angle. So this, remember, is half of the side. In our formula here, though, we need the length of the whole side. Since this is half of the side, to get the whole side, we would take this and we would multiply it times 2. 2 times this would give us 24 times the sine of 36 degrees. This would be the length of a whole side. We would then take this number and put it into the formula over here for the length of the side. 24 times the sine of 36 degrees. I want to simplify this just a little bit and find our perimeter. Our perimeter then, we could say, would be equal to 120. When we multiply the 5 times the 24, it's 120 times the sine of 36 degrees. So this is our perimeter. Now we want to take that perimeter and put it into our area formula so that we have 1/2 times the apothem times the perimeter. 120 times the sine of 36 degrees. Taking your scientific calculator, you should try to punch this in and see can you get the correct answer. Make sure, because you're using sine, cosine, tangent, and we're using degree measures of angles, your calculator needs to be in degree mode. So make sure your calculator is in degree mode. Try punching it into the calculator. Give you a minute to punch it in. You may even want to pause the video. Take time to punch it in. Once you've punched it in, if you've punched it in correctly, you should have found that the area of this pentagon is 342.4 units squared. Okay? All right. Hope this was helpful to you.